At the same time as Bridgewater was building his canal, a young man called James Watt was working out how to improve the Newcomen pumping engine. How's that, Doug?
Very good.
This boiler is supplying steam to an engine that is still doing its original job. It is therefore the oldest working steam engine in the world. And this is the type of engine that set the Duke of Bridgewater's heart aflutter. It performs the same function as the Newcomen engine. There's a balance beam connected to a pump rod which literally pulls water. The other end, we have the piston rod connected to the piston, and it is there that we find Mr. Watt's ingenious new development. This cylinder's got a lid on it, and this is where Watt made his breakthrough. The Newcomen engine relied on condensing happening within the cylinder, so the cylinder got hot, then cooled down. But Watt had an idea. Instead of condensing the steam in the cylinder, so the cylinder is hot, cold, condense the steam outside the cylinder. In this, a condenser, which is always cold, which means that the cylinder is now always hot, which leads us to the next breakthrough. So this is the cylinder that is now constantly hot. It has a lid on it now, so we can no longer rely on atmospheric pressure to force the piston down. But we now have a bonus because we can use steam because it's closed off. So steam now acts on both sides of the piston, like that. So we have a much, much more efficient engine. The Newcomen engine had a 0.5% efficiency. This is 5 times that at 2.5%. Not much, but hey, it was 1812. This engine is controlled from here. And this is Harry, who is the driver. Because even though it's a stationary engine, it still has a driver. Harry, what are you doing?
I'm controlling the steam inlet to the cylinder to maintain the stroke.
How many men would it have taken originally to run this engine?
It took 2 men and a lad.
There's always a lad, isn't there? We've got one. Well! And that is this engine's job. Water. It pumps water. 1 ton per stroke. 1,260 litres. 12 strokes, 12 tons per minute. There's another one. There's another one. This engine's job is to pump water into the summit level of a canal. Engines built on this model, doing all kinds of jobs, would truly shape the world over the next 100 years.